Good morning, everyone, and thank you very much for inviting me to speak today at APC NDT 2023. Confidence. It's hard sometimes to quantify, and it's often not fully valued until it's gone. Taken for granted, you might say. And that's been NATA's specialty for the past 75 years. Offering Australians the opportunity to take everyday necessities for granted and collaborating with those in NDT to produce better outcomes for all. I want to start by painting a picture of what I believe the not too distant future of NDT could look like. In this future world, asset owners will expect real-time information on the integrity of their assets. They will expect to know when the earliest signs of potential failure appear, and they expect to know it before it impacts operational activities. They will want to monitor issues as they arise and choose to correct or modify or repair failures in a controlled, proactive manner. They will want to decrease costs due to failure and improve safety. So how will this look like? There are likely to be sensors embedded in the infrastructure and robots that are continuously monitoring and relaying information to interested parties. Routine, scheduled checks may no longer be required. These checks may be superseded by the vast data lake of information that continuous monitoring is likely to provide. It's a place where the future laboratory uses tools such as artificial intelligence, machine learning and big data analytics to identify the meaningful signals that show potential concerns in the data set for the asset. NDT professionals will be able to delve into the concerns, filter out the noise, and as a result, look at what matters in real time and make better decisions about maintaining the asset. In this future laboratory, I believe there will still be a need for Level 1, Level 2 and Level 3 NDT professionals. And it's my firm belief that key personnel will become more important, not less, with greater adoption of technological developments. In this new world, NDT professionals and the technical control under which they work will need new skill sets that will be more closely aligned to interpreting generated data. They will, of course, still be required to manage the testing and the reporting of non-destructive testing undertaken. However, much of the manual testing as we see it today will become the exception to the rule. Technology operating on the spectrum between sophisticated algorithms and actual artificial intelligence is already available. And automation of testing is not new. Since I started at NATA 35 years ago, we've been accrediting increasingly automated testing across many industries. For example, when I worked in a pathology laboratory, the daily work of a scientist at the bench involved some automated testing, semi-automated testing, and a large number of tests performed manually, using test tubes, timers, pipetters, 37-degree water baths, microscopes, including, might I say, Andrew, some Olympus microscopes, even homemade solutions and reagents. Most, if not all, these tests have now been made obsolete by automation and/or new technologies, and you've probably all heard of DNA analysis. The skill set of scientists in pathology transitioned to the management and quality assurance of these automated processes and a focus on actioning significant or critical results. In the NDT future that I'm referring to, Level 1 technicians might operate such black boxes, doing highly automated testing, as in my pathology laboratory example, and our Level 2s and Level 3s will be interpreting, troubleshooting, and managing a more technically complex set of processes that technicians rarely interrupt. From my perspective, we can look to the past for how best to prepare for this future. NATA has been working with NDT organisations since 1947. Back then, the first registration committee for industrial radiography convened to decide what the criteria would be to allow a facility to be registered with NATA for non-destructive testing. NDT was one of our foundation fields of testing. This image is from the minutes of the first meeting of that registration committee meeting in 1947. Do these requirements look familiar? They probably should. A well-defined range of work, a scope, suitable equipment, competent personnel, laboratory procedures, records, and radiation safety. Non-destructive testing, or industrial radiography, was at the cutting edge of technological development, with radiation safety a key consideration, and controlling technology that had been in industrial use since the 1930s. NATA itself was born out of wartime necessity, ensuring that munitions manufactured in Australia could fit weapons made in the US was of vital importance to the war effort. The importance of traceable measurements, quality control and consistent manufacture and testing, effectively the need for standardisation, was clear to the government of the day, and so NATA was created. In 1950, when W. Edwards Deming was telling Japan's post-war chief executives that improving quality would reduce expenses and increase productivity, Australian NDT facilities were at the forefront of establishing and operating quality management systems as registered NATA testing facilities. Our activities at this time piqued international interest, and our peer review system of accreditation has formed the basis for the establishment of over 100 accreditation bodies worldwide, and through the International Organisation for Standardisation, ISO, the development of international standards for laboratories and for accreditation bodies themselves. The requirements from 1947 are effectively unchanged. From NATA's requirements for registration to ISO Guide 25 and now to ISO IEC 17025, these are still the fundamental components of a competent testing facility. The quality framework that we now expect supports the testing and provides a buffer against staff and equipment changes and other changes that may impact the laboratory's operations. This is how it was over 7 decades ago, and despite changes to technology and customer expectations, accreditation is based on the same principles today and will do so into the future. So why has the system been so successful? NATA's model for peer review assessment uses industry specialists as volunteer technical assessors. Our criteria for their appointment is selective and rigorous. The credentials of nominated technical assessors are reviewed and verified by NATA, and if supported by the Accreditation Advisory Committee, a candidate is invited to join our panel of technical assessors. Technical assessors aren't just knowledgeable, they are at the top of their field, and to be a technical assessor for NATA is a badge of honour. The work of technical assessors is also recognised by many personnel certification bodies, such as AINDT ISO 9712 certification program, as a form of the continuing professional development supporting applications for certification renewal. Importantly, our technical assessors don't just see their role as assessing compliance with standards. They also see their work as a way to give back to the industry, a contribution to the bigger picture. We consider technical assessors to be an integral part of our NATA universe. Their work allows for an ongoing cycle of continuous improvement as they bring the highest levels of contemporary knowledge to each assessment. How does ISO IEC 17025 protect accredited organisations from being limited by the technology of the past? The technical assessors who visit facilities with NATA's lead assessors are up-to-date experts in the fields they are assessing. They know and recognise the changes to technology happening in real time. So when you present a better approach, new technology, or changes to decision-making processes, the up-to-date knowledge of our TAs, together with our lead assessors' detailed knowledge of ISO IEC 17025, ensures the functional engagement of new processes, new technologies and other developments in the assessment process. Technical assessors are in a position to advise NATA about how we can meaningfully assess competency in the new environment. Now, some of these experts are also on NATA's Accreditation Advisory Committee. I've mentioned our AACs already. We rely heavily on AACs across the spectrum of NATA's activities. They advise us on industry activities, trends and current research, ensuring NATA accreditation always remains contemporary. Members of our AACs are also industry-leading professionals. They are appointed by NATA's Board of Directors for their specialist knowledge and expertise. All NDT members of the AAC are current technical assessors. NATA is not alone in supporting Australia's technical infrastructure, called the Standards and Conformance Infrastructure. All pillars of the SCI are vital to the support of Australian industry and the public interest, and all pillars are important to NDT. The Standards and Conformance Infrastructure comprises the development of documentary standards by Standards Australia, metrology and traceability of measurements through the National Measurement Institute, or the NMI, and accreditation by either JASANS or NATA. All of these pillars work together. Standardisation is critical to the process. Without a standards framework, there is no benchmark to identify and define the minimum or optimum process necessary to have meaningful comparability of results. Without knowing that results were validly generated, a user of those test results cannot meaningfully interpret them. Comparability also rests on the traceability of measurements, the assurance that any particular measurement is linked by an unbroken chain of comparisons back to a standard reference. This means that the use of units in a measurement by one facility can be meaningfully compared to the use of that unit by another facility. Australia's key accreditation bodies, NATA and JASANS, support the Standards and Conformance Infrastructure by accrediting conformity assessment bodies. NATA accredits laboratories and inspection bodies. JASANS accredits certification bodies, such as the Institute for its NDT ISO 9712 Personnel Certification Program. So, from the NDT perspective, NATA accredits NDT facilities to affirm their competence to perform NDT activities. These facilities employ AINDT certified personnel to perform metrologically traceable measurements following standard methods. For example, a testing organisation contracted by an aerospace component maintenance company may be asked to perform magnetic particle inspection conforming to AS 1171. The testing facility has a certified ISO 9712 Level 3 who will write the procedure and competent technicians who will conduct the testing and report the results. So we can see that NATA's work is not done in isolation. Together with our partners in the accreditation of certification bodies, in measurement and in standards development, NATA accreditation is part of the hidden infrastructure supporting trade and business. For 75 years, accreditation has been instrumental in affirming the competence of facilities as they adopt more effective and efficient technology. In NDT, we are witnessing the implementation of robotic and automated ultrasonics, as well as a shift from film to computed and digital radiography. And while these moves are happening, we can anticipate the rise of machine learning. In the context of NDT, or indeed in any other modern testing environment, NDT 4.0 is the next toolkit. But the requirement for human oversight is not going away. In fact, it will become more important managing automated systems comprising NDT 4.0. Trust in the competence of facilities using NDT 4.0 technologies will be critical. Together, accreditation of facilities and certification of personnel are intrinsic to the maintenance of that trust. a reliable framework will still be required to control and maintain the reliability of the test results. Accreditation will still be evidence of the effectiveness of that framework. The technology we have now provides more information than the same process was capable of providing 10 years ago. And we're doing more testing now, not less, and that trend will continue. But increasing volumes of data have created the situation whereby having more data does not, in and of itself, lead to better outcomes. NDT 4.0 is about finding ways to transform and translate the data into meaningful, real-time insights. AI and complex algorithms are likely to be generating some automated reports because these systems will be capable of filtering out clearly acceptable and clearly unacceptable test results. In most testing environments, this will reduce routine decision-making. So this naturally increases the time available to spend on challenging evaluations. Humans can spend their time on cases where their skills, knowledge, and attributes are most needed. Skilled NDT professionals will make judgments and write more nuanced reports for asset owners to make their decisions. How can this be done without skilled, capable, and competent NDT professionals? And how can you ensure consistently reliable results without a quality framework to support that testing? For NDT 4.0 to become mainstream, emerging technologies must demonstrate their functionality, reliability, and cost-effectiveness. Increasing industry demands are already driving the adoption of these technologies in other economies. Automated image recognition for dye penetrant already exists in routine production, and there are many academic papers now available talking about the use of neural networks and deep learning for the interpretation of NDT images. To many of us, robots crawling across wind turbine blades is no longer remarkable and is likely to soon be commonplace. As the cost of the equipment falls and it becomes more accessible and reliable, such technology will be introduced into the workplace here and it will become mainstream. All the skills that are needed now will continue to be used, but there is a range of new skill sets emerging. The range of opportunities in this industry is expanding to include things like data analytics, hardware and software development, and the management of AI systems. What competency looks like is going to expand, and it's more important than ever. Certification of personnel to standards like ISO 9712 provides a baseline of assurance of the knowledge, skills, and attributes for those performing and managing testing. Testing and certification of software systems provides confidence in the suitability of the system to be implemented by a facility. Accreditation of the facility, the ecosystem comprising NDT professionals at various levels, the equipment they use, and the NDT 4.0 tools that they use, tells customers, asset owners, and regulators that they can continue to trust your results. Even now, if a facility purchases a commercial, off-the-shelf information management system specifically designed for this industry, it will need to be verified on installation, and any customization or contextualization must be validated. Use of an NDT 4.0 tool will similarly require verification and validation. Confidence in the facility's use of this toolkit can be assured through accreditation. Technical assessors and NATA lead assessors will assess that validation as they already assess the implementation of other automated systems in accredited laboratories. So what might the assessment team be looking at? And here are some possibilities. They could be looking at the proper functioning of the interfaces within the system. They could be looking at how many samples with known characterized defects, reference articles, and unknowns were tested. How many times was each known sample tested? So looking for repeatability. Can the probability of detection for this AI system match or exceed human performance? Are the environmental conditions appropriately managed to optimise performance? What is an appropriate quality assurance framework? How do you know when something has gone wrong? What results require manual intervention, such as checking or further testing? Has robustness been formally determined? Is the robustness known? Where is the data stored? Who owns the data if it's stored in the cloud? Wherever it's stored, is it safeguarded against unauthorised access and tampering? Are changes to the software configuration validated before handling live data? Have data transformations and calculations been validated? How is the trustworthiness of the machine learning dataset evaluated? Now, that's just some indicative questions that assessment teams might be asking. It's not an exhaustive list. And of course, new concerns for facilities to address will always arise. The future is here. Standards Australia says that over 4,000 new standards will be necessary in the next decade to support the rapid pace of digitalisation and scientific advancement. A core aspect of NATA's purpose has always been and continue to be risk mitigation for asset owners and decision makers in Australia. We are here to support decision makers and deliver confidence in test results. No matter the changes of inputs, be they hardware, software or human, there will always be a need to provide assurance of test outcomes by an assessment of the processes and techniques used to generate those results. We've seen in other markets and industries with more mature adoption rates of AI that humans remain vital to the generation of trusted testing results. NDT is at an inflection point. Automated systems are starting to recommend further testing where it may be required, but ultimately the decision-making is still a completely human process. In the near future, we are likely to need more specialists to help evolving automated systems resolve data into meaningful information. It will be the responsibility of the NDT professional to understand enough to evaluate the results that an automated system produces and not unequivocally accept what is offered. I've spoken about how the tools of NDT are changing. Yes, it's true that techniques and technological advancements are evolving, yet Australia's standards and conformance infrastructure supporting this innovation will be crucial to its ultimate success. The fundamentals of what makes a quality organisation will not change. Ensuring levels of competency for both those systems and personnel will become even more important as job roles and skills shift. Our peer assessment model, using experts in their field, ensures NATA will always remain contemporary for NDT and reflect its best practice, no matter what the future brings. The way we understand and apply the clauses of ISO IEC 17025 will change as it's applied to technology that was unimagined at first drafting. But the principles, the fundamental criteria needed to issue quality, trusted reports will not change. Across industry, the technology in use may differ significantly from one organisation to another, but the requirements for outcomes to be technically valid and trusted will never waver. The future may be unknown, but whatever NDT 4.0 brings, we look forward to working alongside all of you as accreditation continues to provide assurance in testing results and confidence for asset owners for the next 75 years and more. Thank you again for the opportunity to speak to you today. I wish you all well for the remainder of the conference.